Hello and welcome to our second installment of Continuation of Instruction. Hope that you are well. Life has definitely been interesting here in our household. I'm sure it is just as interesting for all of you guys. I worry about you. I wonder how you're doing in your day and how things are going. I know it's tough to be cooped up and out of routine for so long, but hoping that bringing you this instruction will help give you a little normalcy back in your life. So, let's review. Our first installment was about reflection. And reflection is when you take an object, let's say like the number 3, and when you reflect, let's see if I can do this with this. You can reflect over the y-axis, which means it becomes a mirror image left to right. Or, if I can do it again, you can flip, let's see, over the x-axis, depending on where you place your object. And these are two types of reflections. And the next type of transformation we're going to discuss is translation. Translation is where you're simply going to move the object. So translation looks something like this. It doesn't have to be exactly in the same place, but it will maintain its size and its shape. It is simply just changing location. So, more on that by using our notes. You're going to take out your math packet, turn to, believe it's page 3. So here we have our notes, and it says a translation is a vertical, which means up and down, or horizontal, which means left and right, slide. As you saw me demonstrate with the number 3, you just slide it to a new place. I'm going to do these notes a little differently. I'm not going to fill in this top part yet because I think that the symbolic form can look a little intimidating. So we're going to start with the actual examples and then we will go back and fill in the symbolic part afterwards. So triangle ABC with vertices listed there, and then they provide the symbolic notation. So what is a vertice? A vertice is the point where two lines meet. This is a vertice. A triangle has 3 vertices. A quadrilateral has 4 vertices. Okay, the vertice is where 2 lines meet. So that vocabulary term is pretty important for you to understand. Next, we need to go ahead and draw the triangle. So we're going to go -6, 4. That's -6, +4. B is +4, 1. And C is -7, -1. Now notice, unlike reflections, these vertices are located in 3 different quadrants. That can happen with reflections as well. We just focused everything in one quadrant to kind of make it easier for you. So once we have our 3 vertices graphed, the next thing we have to do is focus on the rule. And here we're given the rule. You're either going to be given the rule and you find the new vertices, or you're given the location of the new vertices and you have to define the rule. So here they gave us the rule. They're saying take every x coordinate and add 3. Well, how do you know if you're going to go left or right or up or down? Well, first off, it's to the x coordinate, so it's automatically going to go left or right. If it was the y coordinate, we would go up or down, but x coordinates only move left and right. So you're going to take every x coordinate and you're going to add 3. That means we're going to go to the right 3. Because remember, if you're just looking at a number line, right, and this way, here is 0. This is the plus side, this is the positive side of 0, and this is the negative side. So if we're going to add 3, we're going to go 3 to the right. So what was the x value of the vertex A? It was negative 6, comma 4. And so the x value of vertex A was negative 6. So if I go to the right 3 plus 3, that would be this point here, but that's not our location because we also have to then add 2 up. So we're going to the right 3 and then up 2. And so our new location adds 3 to the x value and adds 2 to the y value. So therefore our new location is negative 3, positive 6. And if you look at what it was, negative 6 plus 3 more is negative 3. And 4 plus 2 is 6. And so our new location is negative 3, positive 6. Okay, so that was a lot to take in at one time. Let's go back and think about this. This is our rule. For this problem, this is our rule. It is take all your x values and add 3. So what is 4 plus 3? It's 7. And what is the y value plus 2? Well, what's 1 plus 2? It's 3. So 7 comma 3 is our new location. So let's go 7. And up 3. And that's going to be our new B location. This was B. This is B prime. This was A. This is A prime. Okay, so now we just have to find C prime. Okay, I paused the video because I wanted to redo everything. I had colors going everywhere, and the colors were not helping. They were distracting me, at least. I feel like now they're going to be more organizing. So here are original vertices, our original triangles all in purple, and our new points are all in red. And so we're taking the original point, negative 6 comma 4, and we added 3 to the x value. Negative 6 plus 3 was negative 3. And we added 2 to the y value. So 4 plus 2 is 6. And we got this new location of negative 3 comma 6. And we graphed that. And now we took the same rule and applied it to B. And we said that 4 comma 1, if we added the rule was add 3 to the x value, we got 7, and add 2 to the y value, we got 3, and so our new location was 7 comma 3. So that gave us B prime, and now we need to find C prime. Our original location is negative 7, and we're going to add 3 because the rule here that we were given is to add 3 to the x value. So negative 7 plus 3 is negative 4. And then we're going to add 2 to the y value. Negative 1 plus 2 is positive 1. So now we're going to graph that point. We're going to go 1, 2, 3, 4, and plus 1. And there's C prime. And now we graph our new triangle. And it hasn't changed size or shape. It's just been relocated. So why don't you go ahead, pause the video. I don't want this to be another 25-minute video like the last one. See if you can try number 2 on your own, and then we can check it. Okay, so to go over this one, I've already graphed the initial trapezoid. The trapezoid has 4 vertices, and 2 of them are going to be closer together, as you see in K and N. Looks kind of a funky square, right? It's a trapezoid. So we need to translate this one into a new location. And to do that, we're going to follow this rule. We're going to take the K values and subtract 8. So what is 1 minus 8? Well, that would give us negative 7. And then what is 3 minus 7? Well, that would give us negative 4. And so now we're going to take that new location, negative 7, and negative 4, 1, 2, 4, and we're going to put that spot, oh, there it goes, right there. And that's going to be K prime. Our new location for our L, again, 2, 7 is the original location. So 2 minus 8 is going to give us negative 6. And 7 minus 7 is 0. So we're going to go to negative 6 and 0. And that's going to be L prime. For our M location, it is 7 comma 2. 7 minus 8 is negative 1. And 2 minus 7 is negative 5. So minus 1, minus 1, 2, 3, 4, 5. And this would be M prime. Let's take the eraser, make some room for us. Again, we're taking each original location. So the original location for N is 3 comma 1. We're going to then use the rule, the x value of 3, and take away 8, because that's what the rule is asking us to do. 3 minus 8 is negative 5, so 1, 2, 3, 4, 5, and then take the 1, the original location, the original y value was 1, and we're going to subtract 7. And that's going to give us a new location of minus 6. So negative 5, negative 6 is going to be our N prime. Negative 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. And there's our new N prime. Again, it's not reflected. It is simply shifted. We picked it up and moved it to the left and down. We moved it to the left 8 and moved it down 8. And I know it was going to go left and down because we were going X, we were moving it negative, and Y, we were moving it negative. Let's take a look at number 3. What can we expect to happen in this before we ever start to graph anything? We know that we're going to shift to the left because it's asking us to move our X values all negative 7. We also know it's going to go up this time because it's asking us to take all our Y values up 3. Let's take a look at number 4. What can we expect in number 4? Well, we know we're going to go up, to the right. See, we all make mistakes. We're going to go to the right 9 and down 4. Okay, so hopefully you can get the hang of this because this isn't going to change. Very predictable rules that anytime the X is negative, you're shifting left. Anytime it's positive, you're shifting right. Anytime the Y value is positive, you're shifting up. And when the Y value is negative, you're going to shift down. At this point, I want you to go ahead, practice 3 through 6 on your own. I'm going to place the answer key to this sheet into Schoology. You can fill in the top section with the rules up here, and check your answers that you got in 3 through 6. The second page we will do in a different video.